Well, welcome everybody and to our May edition of the ABA Engineering Academy's engineering webinars. We've been holding these things since last year, and we've really had some good guests and a lot of good participation. And we want to welcome everybody to our webinar today. If you want to ask a question to our guest, all you have to do is click on the chat button down at the bottom of the top, depending on which operating system you're using, and you can just type it in and we can see that and relay it to our guests. But we're looking forward to that. Want to remind you that we have our newsletter that goes out every Monday at about 5:20 in the morning. And if you are not on the mailing list for the newsletter, just drop us an email and we'll be glad to put you on that on the list as well. We also started about 3 weeks ago another newsletter that goes out on Wednesdays. One will go out tomorrow for pro audio. We found out that there's a good number of engineers in the broadcast industry that also work in the pro audio, either in the live area, mixing audio at their church or for concerts or clubs or whatever. And also maybe even work in the mixing. You might have a little mixing studio at your home or somewhere where you mix for bands and all. So we put out a newsletter for that as well. So if you're not on the mailing list, not getting those, let us know, and we'll be happy to actually have you a part of that. I want to introduce our co-host. I think John George. I think you. Let me get off the sharing here. John, I think you're around, and I want to throw the program over to you right now.
All right. Well, thank you very much, Larry, and good morning to everyone, and glad to have Shane with us today. Just wanted to mention, as we do tidbits from the FCC each time we get together each month, and this month it was brought to Larry and my attention that the commission is definitely looking at translator antennas that have been installed on the translator stations. A lot of people don't realize that there is a requirement that in order to change an antenna for a translator, you have to file that information, an application with the commission. It's not like a standard FM where in most cases you pick the antenna you want, and as long as it meets all the requirements for your needs to reach the proper ERP, everything is fine. With the commission, when you file for a construction permit, you designate the antenna you plan to use, and they expect that antenna to be the one installed unless you file a different construction permit. We do know of several stations very recently that had their licenses rescinded even after operating for some period of time, because the commission discovered that they filed for one antenna and they were actually using an entirely different antenna. So that's something that all of us should be checking for our clients that we have, to be sure that the antenna that was called for in the construction permit is actually the antenna that's on the tower. And that's all that I have. Larry, back to you.
Okay. Also, we want to remember to remind people, because I keep getting emails from different stations about if you're running a translator off of an HD channel and that HD channel fails, that translator has to go off as well.
That is correct. It's just the same for AM as it is for HD. If the main carrier and audio is off, then the translator needs to be off.
Yeah, that seems to be a problem that people still run into, that you may lose the exporter and you lose your HD2 and 3 and you got a translator on them. Well, they want to just keep running the translator, but that's a no-no for the commission, so you can't do that. So make a note of that. Another real quick note before we introduce our guests: the ABA will hold its annual convention August 13th and 14th in Birmingham. And so mark that on your calendar. We'll have a good lineup of presentations on our engineering day, which will be on the 13th, I believe. So, and we'll have some more information in our newsletter about that. Well, our special guest today, if you have been in an airport anytime recently, you probably saw this gentleman, because I think he's visited just about every airport there is here lately. He's always on the go. Shane Toven, he is with K-Love and Air One, he's had a long history in broadcasting. He started when he was 13 years old, and now you just got to have it in your blood, I think, Shane, to be in it that long. But we want to welcome him to us. Shane is doing a lot of work now, I think, with installing studios using audio over IP, and we thought it would be good for him to be with us and talk about the proper planning and installation and layout when you're going to convert your studio or build a new studio using IP. So Shane, the program is yours.
Thank you, Larry. So yeah, I'm today I'm going to talk kind of talk a little bit about. We're going to go back to a kind of a high level view here before we talk about studio design. We can kind of get into that after the or during the session. If you have any questions as I go along, this really is meant to be kind of an interactive session. So please go ahead, put them in the chat, and I'll do my best to watch that and answer them, or feel free to, I think you can turn your microphone on and ask as well. But yeah, definitely do feel free to interrupt me. This is definitely going to be an interactive session. I've got a lot of slides here, but if we have to zoom through some of them, then we'll certainly accelerate a little bit. So ITN broadcasting, IP and AOIP 101. So why is this important? We're no longer just broadcast engineers. We've actually become IT personnel. So in addition to servers and desktops, most modern broadcast equipment has an Ethernet port and an IP address. And the world now pretty much revolves around IT. Even simple devices such as thermostats have become connected. It's called IoT, or the Internet of Things. So let's talk about some of the systems that we have to support as engineers. We have to support the traditional systems, of course, like desktop computing, file servers, network switches and firewalls, telecom, POTS, ISDN, T1, Voip, maybe less so those first three these days. But now also the broadcast-specific systems, such as automation servers and workstations, audio over IP, transmitter and site control, and also, like I said, telecom, which, includes the studio phones and audio links, in addition to just the regular office phones. So for years, most of us are familiar with troubleshooting things by looking at the signal flow. Well, it's really no different in an IP system. So where does the signal start? Where does the signal end? And what's in between? And I always like to reference the 3 rules of rock and roll. They still apply. Is it plugged in? Is it turned on? Is it turned up? It's the same basic process for any system. You follow the path, you look at where the signal stops or the issue begins, and you try to isolate the problem. And some signal paths are certainly more complex, but the basic process is still the same. I'll make a quick note here that I didn't put in my slide. Well, actually, I did put in my slides. I get into it here in the next section. Documentation. Create or update documentation as you go. It's tempting to let the network kind of stuff become self-documenting, but that gets to be a little dangerous. I mean, yeah, networks are pretty dynamic systems. AOP, things are constantly changing just by the very nature of those systems, but please, 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 please take the time and document. It will save you so many headaches down the road if you just continue to document things. Yeah, I mean, if you think you don't have time, imagine how much time it's going to take you later when you have to kind of go back, retrace, and remember what you did or how this system works. If the facility isn't well documented, to take a quote from my favorite, my friend Napoleon here, you're going to have like the worst day ever. So some first steps in troubleshooting things. Check the obvious. Any meter readings, if applicable, look at the device. Any indicators not lit that should be. Any indicators lit that shouldn't be. And look for power, signal, alarms, etc. So is there any odd smell coming from a piece of equipment? Anything look discolored or scorched? Any strange noises? Is there an alarm beeping? Is the fan noisy, etc.? Is there anything that seems abnormally warm? Assume nothing. Okay, so let's talk about some tools. First tool of the trade, your senses. Use your eyes, your ears, your sense of touch, your sense of smell, your sense of taste. Okay, maybe not so much. One that comes in really, really handy in a modern facility is the network cabling analyzer. Now, these come in all kinds of forms. The picture I show here is of a little fluke analyzer. I think you can find these for under $1,000 thereabouts, but they will actually tell you not only that you've got a good cable, but tell you that that cable is actually performing up to spec. You can identify your cable runs, you can certify the performance level of your cable and your terminations, and do some basic network diagnostics. Some of these even allow things like ping and traceroute built in. Maybe provide power over Ethernet to power the remote device. But unlike just a basic cable tester, which only tests continuity and pair order, this actually does test the quality of your cabling and terminations. And it's really important to have something like this in your modern IP-based facility. Otherwise, you're just kind of shooting in the dark. You can have a cable that, continuity-wise tests perfectly well at DC, but as with RF, you think of it the same way. Basically, these twisted pairs are carrying, when you think about it, RF signals up to like 500 megahertz or more. You have to kind of quantify that somehow. And a lot of times, though, if it's part of a new build or something, it could also be done as by cabling installers as part of the overall project. One other handy tool to have in your toolbox is a small managed network switch. I've got a picture of a little Netgear switch here, a little 5-port switch. These come in really handy to create a small little network for troubleshooting things. It allows you to monitor data on an Ethernet connection to or from a device. Some of these can actually act as like a tap on the line, so you can put it in line with a suspected a suspect device or suspect port, and actually use something like Wireshark, which we'll talk about in a little bit, to monitor the data on an Ethernet connection to and from a device. You can use it to troubleshoot VLAN issues, and we won't get too deep into that, but VLANs are virtual LANs, virtual local area networks that allow you to, on the same physical hardware, separate off different networks. That's different from subnetting something out, although you will have different subnets on each VLAN typically. But what it does is it isolates that traffic such that unless you explicitly route it, it's only going to be limited to that particular VLAN. But yeah, sometimes those can have some issues that you may need to troubleshoot. One other really handy tool is a little travel router. Again, this particular little one that I pictured here is from TP-Link, but there are a whole number of them out there now. Some of them even include LTE connectivity. So you can create a Wi-Fi hotspot from wired Ethernet with most of them. You can connect devices that are wired only to Wi-Fi networks. Like I have a spectrum analyzer, for instance. It's an Agilent Field Fox. It only has Ethernet. So I can actually connect it to this and attach that to a Wi-Fi network if I need to. You could share USB drive content over Wi-Fi or Ethernet. And like I said, some models can even connect to an LTE network. The next tool, and this one's pretty obvious, is a laptop. You can use it to store your documentation, and that's actually a lot more handy. I mean, I know a lot of people are really big on paper documentation, and that's great, but paper documentation has a nasty habit of getting out of date fairly quickly. With your laptop, you can, again, pretty much just update as you go and, keep PDFs. And yeah, okay, I know some people go, well, I can't write on a PDF. Well, some laptops you actually can. If you've got one that's got like a little pen, little pen input or a touch screen or something, you can, you'd still do markups on those by hand if you'd like. It's useful for equipment configuration and test, network troubleshooting, There are a bunch of tools that you can use for network troubleshooting. Some of them actually are part of the OS. Some of you might have to download. Ping and Traceroute are pretty basic ones to tell you, A, if a device is alive and responding, and B, how the traffic actually gets to that device if you're going over a few routers or something along that path. Nmap is kind of an interesting tool. It'll scan for open ports on a device. That can be used for good or bad. We use it for good in our applications, just to make sure that ports that aren't open to the ports that shouldn't be open aren't open, and ports that should be open are open. Again, that's the kind of thing you also want to use and test against your firewall to make sure your firewall is only allowing through exactly what needs to be allowed through. PuTTY, yeah, it's kind of like a well, it is. It's a Telnet client. Telnet is unencrypted, but there's also SSH, which is encrypted, and PuTTY allows you to connect via kind of a terminal link to any of those and get at those command line type of resources in these devices. Snmp, it's another commonly used protocol in broadcast these days in terms of managing devices. It stands for Simple Network Management Protocol. Well, it's really anything but simple, and there have been other presentations on just on Snmp, but there are tools that you can use to actually troubleshoot that as well. And then finally, Wireshark, they talked about earlier. It's a really comprehensive kind of packet capture utility. It's a little bit of a learning curve on Wireshark, because it'll give you a ton of information. It literally will capture anything coming out of that port and record it and show it to you on your screen there. And then you kind of have to learn how to interpret that. But you can limit it to, okay, this is the device I'm sending from. This is the device I'm looking at. What's going to it? What's coming from it? What am I not seeing that I expect to see? Onboard Ethernet on a laptop is another important feature. Now, it's kind of becoming less common in a lot of laptops. You'll see a lot of newer laptops may only have something like USB-C. Some of the more powerful laptops may still have some additional extra ports here. The one I show here is an HP EliteBook. That one actually has a pretty comprehensive selection of ports on it. It's got Ethernet, USB, it's got USB-C as well. Yeah, so, but if you don't have an Ethernet port on board, you can always use a USB to Ethernet adapter as well. So another one that's still important is a USB to serial cable to communicate with legacy equipment. Now, with these, you really have to be careful. It's a case of buyer beware. There are a lot of them out there that use counterfeit chipsets, and they just won't work. So usually you want to find one that's got fairly good, if you look on Amazon, for instance, find one that's got fairly good reviews, find one that's not the dirt cheapest thing that you can find out there. Try to find one that's actually some kind of brand name that's recognizable, not just some random thing. You want to make sure it's tested regularly. Software and driver updates do tend to break those cables. There's nothing worse than getting out into the field, trying to plug into something, and then realizing, oh wait, my USB to serial cable doesn't work. Yeah, serial ports, they're, for better or worse, they're out there still, and I don't think they're going anywhere anytime soon. They're still a great way to get into equipment for initial configuration and troubleshooting. So the next one here is a tablet. Obviously a lot of the same purposes as a laptop, but just a little bit more portable. Again, documentation. It can act as a hotspot if you've got LTE on your tablet. I know that's something that we do around here quite a bit, especially in the field. You can use it for equipment remote control, especially browser-based remote control for equipment. And there are a number of various helpful apps and network troubleshooting tools depending on the platform. I show an iPad here, but I know not everybody is into Apple and into iOS and all that fun stuff. There, Apple, Android, whichever platform, there are a whole bunch of networking tools out there you can get. You can even get an adapter to plug into a wired Ethernet network for these devices if you really need to. It allows remote access to other systems as well. And again, the big advantage is that it's really compact. Yeah, you may or may not be able to use an Ethernet connection. I'm finding that you actually, it's more common now that you actually can get an Ethernet adapter. Even on Apple, you can find Ethernet adapters for these that will plug in and work. And you can, barring that, you can still connect to Ethernet devices over a portable router if you aren't able to get a direct Ethernet connection from your tablet. So let's talk a little bit about some cable terminations. Most commonly, you're going to see these guys, the RJ45 connectors that we all know and love. These can be used in place of most other interconnects in a facility. They have a very compact form factor, which means high connection density. You've got 8 pins in each of those, and they take up literally about 1/4 of an inch apiece. They can be used for many types of signals. People think of them traditionally just as Ethernet, but you can also use them for other things. Things like, there's a standard out there called Studio Hub, now owned by by Mike Dosh and Angry Audio Company. They make some really cool little gadgets. It's not Ethernet or IP, but what it does is it physically and electrically converts to and from other signal types or other types of connectors to RJ45. It does not actually electrically change the format of the signal, but it does allow the use of a common cabling infrastructure. So all of that Cat5 that you've got pulled through your facility, it can be used in place of other dedicated analog and AES and DC cabling. Standard RJ45 patch panels allow for easy routing and infrastructure changes as well. And what's really nice is that if you do hire a structured cabling vendor, this stuff can be installed by IT and cabling personnel that aren't familiar with broadcast standards and requirements. You just say, hey, I need this many pairs from here to here, put patch bays in, and there you go. No more punching down to 66 blocks and stripping and soldering and all of that fun stuff. But you do want to ensure that you're using the right connectors for the right cables. So Cat6 particularly, it was a little bit different from the Cat5e cabling. So another one that you want to watch out for is stranded versus solid cabling and connectors. Stranded cabling is typically used for patch cables between devices, whereas solid cable is typically used for installation purposes. Solid cabling, it's not going to stand up to repeated flexing and abuse very well. It may be prone to failure, but stranded cable is a lot more robust that way. But you do want to make sure you're using the correct RJ45s for that. I'll take a quick note here about things like Cat7 and Cat8 cable. Cat7 was kind of an oddball. It was never quite really ratified. Cat8, you may think, okay, higher cable number, better, right? Well, not necessarily. Cat8 was really designed for really short, high-speed interconnects within data centers. It will still work for typical Ethernet, but it's kind of you're just as well off going with Cat6 or even Cat5e. I would say at least pull Cat6 though. That's if you're going to pull new cabling. So now let's talk about the signal types that we might run over these types of connections. DC. We could run serial either for control or metadata. And of course, custom and proprietary schemes. And then, of course, audio over IP. Audio over IP will replace most analog and digital connections within a plant. It only requires the discrete connections at devices that don't natively speak AOIP. There are various schemes and manufacturers for AOIP. First, we've got Livewire, which is an Axia technology. They were one of the first to be doing this in a broadcast application. There's WheatNet, and now one that we're starting to see a lot more of is Dante. Dante is kind of cool in that they've got it initially started out more in the live sound and kind of pro audio world, but it's becoming more common in broadcast now. And, they all basically have the same, they all basically do the same things. I mean, they're all transporting audio over an IP network. It's just a matter of, what the various schemes and packetization looks like. So there is an industry standard now called AES 67, which will allow these various different manufacturers' devices to talk, mostly. So you can get audio back and forth between devices, but control is still something that has to happen independently because each of these manufacturers kind of has their own proprietary control schemes for their devices. So we'll talk a little bit about voice over IP, which is similar to AOIP, only it's more designed for telephony than passing broadcast quality audio. Not to say that it can't, depending on the codec that's in use, but typically we think of that as replacing telephony. So like POTS, T1, and other legacy voice circuits. Uses industry standards such as SIP, which is Session Initiation Protocol. That's basically how VoIP devices set up connections between each other. You could see it in studio phone systems such as the Telos VX that I have a picture of here. But it'll also integrate with audio over IP systems and office VoIP systems. And again, these are because of the standards that exist, such as SIP. And VoIP is going to give you considerable flexibility compared to legacy telecom circuits. I'm willing to bet that if you priced out the cost of moving to VoIP versus what you're paying right now for your traditional circuits, you probably would be really surprised. And your GM might actually be kind of happy that you could save them some money by switching to voice over IP. We're going to talk about encoded audio now using audio codecs. So these will replace ISDN, and ISDN these days it's pretty much all but dead. There may still be a few areas supporting it, but it's dying a slow and painful death. There are a mix of standards and proprietary encoding among audio codecs, but they often incorporate VoIP technologies such as SIP to set up sessions between them. It's designed for passing encoded audio or bit-reduced audio over the public internet or across private links with limited bandwidth. So now we'll talk about control and metadata over IP. This is going to replace GPIO and serial connections. It can be independent of the audio or in some cases embedded with the audio. There are various proprietary schemes for this. And there are some standards for it, but it's still very much a work in progress. One thing that really comes to mind in particular is RDS. I know a lot of people have some pain points over that because there doesn't seem to be any one hard and fast method for for doing RDS and communicating between automation systems and encoders. I mean, there is a standard. I forget the name of the encoder standard now, but it was more widely deployed in UECP, Universal Encoder Control Protocol, but it was more widely deployed in Europe than in this country. We use ASCII plain text a lot more here to control encoders. But what the data looks like coming out of your automation system versus what the encoder is expecting, it may or may not match up. A lot of times there's some middleware involved there that has to translate between your automation system and your RDS encoder. And then if you've got HD radio on the air and streaming, those are yet two other destinations that you have to take into account. Other types of IP traffic, as I mentioned, streaming audio, which may be done in-house or sent out to a third party. Your internet access, your various office functions such as file sharing between users, and nearly anything else. So now we're going to talk about the types of equipment that we use for audio over IP. They're typically called nodes or blades or something to that effect. The end devices that convert to and from audio over IP, to and from analog or digital audio. Yeah, it's just an end device that converts uncompressed audio and control to and from the audio over IP domain on a local area network. other AOIP capable devices, some satellite receivers, some audio codecs, automation systems, PCs, and digital audio workstations. Now, this is kind of cool. For years and years, we've had sound cards in our PCs and our automation systems and our our production workstations. Well, now you can literally load an inexpensive audio driver on there, connect it directly to your network, and suddenly now you've got multiple channels of audio in and out of that device without a sound card. It's just talking natively to your AOIP network. That can save a lot of money and a lot of time and a lot of headaches. Your Voip broadcast phone system, basically it acts like a gateway between the voice over IP realm and the audio over IP realm. So again, similar technologies, but different purposes. So IP codecs, like nodes and blades, but they have the specific purpose of handling bit-reduced audio across a lower bandwidth connection. Audio consoles. So the one I show here is an Axia Quasar in particular. It's the physical control surface for mixing audio. So these are what you would put in your studio in place of your traditional analog audio console. It's not actually handling the audio. It's basically just sending commands to devices elsewhere on the network. Think of it as a giant keyboard and mouse, essentially, to kind of oversimplify it. Failure doesn't take it off the air, but you may lose control from that surface. This particular one, again, the Quasar, it's banks of 4. So you could maybe lose that bank of 4, say if somebody spills coffee into it, but it doesn't take you off the air. You just lose whatever control you had on those faders, but you can easily assign that stuff to other faders. And it's like nothing ever happened. Basically, you just lose 4 faders. So nice thing is with AOIP, you can assign anything, anywhere. You can implement consoles either in software or hardware. This is kind of cool because, for instance, if you've got a prod room and you go, okay, I don't want to spend money on a hardware, on a surface just for a prod room that's going to get used, maybe a few hours a week or whatever, you can actually do software consoles. Now you can actually do them over the web as well. So you can do, basically you can have your console right there in a browser. Again, you want to make sure that that's secured access to that, not just available to the outside world directly. But yeah, there are a whole bunch of options. And now, with more work from home and things like that, it's something that can really make life a lot easier. The next part is the mix engine or blade or whatever it may be called. So down there I show an Axia power station, which basically is an all-in-one device that has some audio I/O. It has a power supply. It has mixing capabilities and some GPIO. It was used with another series of console. The Quasar actually is a little bit different in that regard, that it has a different type of mix engine. So they take any device on the network that routes and mixes multiple sources. It's controlled by a physical console surface or a virtual console or some other means. Maybe you've got an automation system or something that would be talking to this and controlling its various mixes. For example, in my facility here, we have several different program services that may be originating out of any of several different studios or locations. So what happens is they all go into these mix engines, into a virtual mixer, and then an operator will take the appropriate one at the appropriate time, and then the output of that mixer is what feeds everything. That virtual mixer is what feeds everything else. So there's usually one dedicated per console, but it can also be a shared resource. And in some cases, like I said, it may be integrated with the console. So the networking equipment behind all of this, network switches. Typically, you would have smaller edge switches in the studios and the wiring closets, and a large core switch in your main tech area. So it'd be kind of almost like a hub and spoke type of approach. And these switches typically, in most installations with AOIP, you're going to want to see them dedicated, but I do know there are some facilities that share them for various reasons. And that's where those VLANs and various other configurations come into effect. Something you want to do very carefully. You'd want to consult with your manufacturer on that, and whether or not that kind of interconnection. It may not be something that's that's actually really desired in most facilities, but there can be certain cases where that might be the way to the way they need to do it. So again, talk to your manufacturer. Really think about what your needs are. Smaller facilities, you're probably going to be talking about dedicated switches for your AOIP network. Routers, not to be confused with audio routers. They basically link different networks together. They can have some firewall functionality as well. Now, typically, a lot of these routers are not going to be high speed enough to really handle AOIP traffic. Those get to be some really, really high-end routers. And again, that's kind of the exception rather than the norm. But what it can do is it can route control traffic in and out of your AOIP network if necessary. Again, something you want to talk to your manufacturer about, or something, if you've got an IT person that you work with, something you'd want to talk to them about as well. It's basically just to connect different networks together and provide some isolation as well for things that should pass or shouldn't pass.
Jane, while you're on that subject of engines and all, somebody asked me one time about redundancy, and I've seen systems that have an A engine and a B engine, and some even go as far as having dual networks. Talk a little bit about that, if you would.
Oh, sure, absolutely. So yeah, you can actually have redundant resources available on the network. If you've got a second engine there, basically it can be sitting there taking your sources just the same as your current engine is. And if it fails, you can always just switch over to to that backup. I mean, the challenge comes with having multiple consoles talk to an engine. They're not always designed for that, but at the very least, you still have control of that engine directly, regardless of what's going on. And if you've got two of them with the same sources coming in, especially if you've got some automation, you could easily have that happening simultaneously. And yes, you can actually have redundant networking on these as well. Dante is one in particular where every single device has a primary and a backup port on it, and it's designed that way such that you can actually have two fully and completely redundant networks operating simultaneously. So there are certainly options for that. You can make systems like this as robust, basically, as your budget allows. And there are any number of levels of that and options for that. Does that answer your question?
Yeah, I think on a bigger installation where you're in a big market or something, you don't want to rely just on one engine.
Absolutely.
If you lost that engine, then you're in a world of hurt. So
yep, absolutely. So most commonly, even in smaller markets, what you would typically see is you would have consoles, multiple consoles you'd have a console in each, in different rooms, and you would have an engine associated with that console in the other room as well. So what you could do, I mean, in worst case, is just switch from one room to another. I mean, even in a small market, that might be your backup strategy, or you switch to a virtual console on a different engine. And just mix virtually until the issue can be addressed. Matt says many AOIP have at least auto silence sensing if a blade segment is lost, and that's correct. Yeah, so a lot of these do have some of this kind of test and measurement functionality built in as well that allow a lot of intelligent actions to be taken without any kind of operator interaction. So you can program any number of scenarios into these devices and get some very robust backup schemes set up. So speaking of, let's talk about troubleshooting. It gets a little bit trickier since Ethernet and IP paths can carry multiple types of data and take multiple routes. It's the same concept as any other signal flow, but it's just, you have to think about it a little bit different way. So one thing that becomes important in networking is the OSI model. It's something that a lot of people have a little bit of trouble grasping at first, but I look at it as almost kind of like a layer cake. So you've got 7 layers to the OSI model. First is the physical layer. That would be like your actual physical connections, your Ethernet connections to your network cards and to your switches. the data link layer, which is where we start seeing the Ethernet portion come into play. That's where your MAC addresses and all of that stuff would reside. The network layer, that's where things like the IP protocol actually reside. Transport layer on top of that, the most common ones that we think of in transport would be things like TCP and UDP. So often you'll hear things referred to as like TCP IP or sometimes UDP IP. So that's the combination of the layer 4 and the layer 3 protocols kind of working together. And the other 3 layers, they more get into kind of the user end of things and interaction with everything else. So I won't go too much into those in depth, but yeah, at the very least, you're probably going to want to have a pretty good understanding of layers 1 through 4. So possibly layer 5, depending on what you're trying to troubleshoot. That gets into things like HTTP and things like that. So various other protocols. So you first want to troubleshoot your physical links. Again, layer 1. You look at link and activity LEDs on the Ethernet ports. You can swap Ethernet cables and or patch ports. Maybe you've got a bad port on a switch. Maybe you've just got a bad cable. One that's really burned me in a few cases is a lot of people like to buy these pre-made short little patch cables for their patch to, if they've got a patch bay next to a switch, they just make these short little patch jumpers. Some cases with a few vendors, I won't name names, I've had a few of those bad, and no real rhyme or reason to it. It just either didn't link up or it would link up at a lower speed than you would think. That's another thing you could check. Make sure that it's linking up at the speed that you're expecting it to. Most devices are going to be at least 100 megabit. Some older devices maybe 10 megabit, but these days you're seeing a lot more and more gigabit capable devices. So you want to make sure that it's actually linking at that full speed, whatever the device is capable of. You want to check any interconnecting wiring as well between the locations. Are all of your pairs in the correct order and polarity? Again, this goes back to the cable testers and that I mentioned earlier. So 568A versus 568B can cause some issues. What's interesting is they are electrically identical, but they can cause issues if they're not consistent within a plant since the color codes are different. Most commonly now, you'll see 568B used. If you take a close look there, what you get if you have 568A on one end and 568B on the other is you'll see that the white-orange pair and the white-green pairs are reversed. So what do you get when those are crossed? You get a crossover cable. Not as much an issue, I guess, anymore, since most devices will auto-negotiate that, but you still want to be consistent in your wiring throughout your plant. So the next thing, as I just mentioned, layer 2, speed and duplex issues. They can sometimes be set incorrectly, especially if you've got a managed switch or looking at your NIC. They should almost always be set to auto on both ends, or in rare cases, you might need to force them to the same setting on both ends. But maybe you've got a switch that somebody did force it on one end and it's set to auto on the other end. Now, again, depending on the speed and depending on 10100 or gigabit, that may or may not negotiate if you've got auto and hard auto on one end and hard coded on the other end. So typically we'd see the same setting on both ends, regardless of what that is. Next, you want to troubleshoot the actual equipment. If you've got something that just refuses to link regardless of what you plug it into, maybe you do some ports work, but others don't? Is it dead entirely? Is it passing other traffic, but not for a specific system or device? If it's a switch, for instance, maybe you've got a switch that some ports have been programmed as disabled for some reason, or they've been set to administratively down. Like I know in Cisco's that can be a common thing. I had a situation just the other day where I was plugging a device into the network here, and the port got disabled because it didn't like what it was seeing from the device I connected, which happened to be another switch. So that was sending out some traffic that the other switch said, no, you shouldn't be sending that. Bye-bye. So it shut me down for 5 minutes and kept doing that repeatedly until, until I corrected the issue and said, okay, my switch is not going to send those packets anymore. So VLAN assignment issues, I talked briefly about this earlier. Again, this is more for managed switches. In many cases, ports are assigned to specific VLANs depending on the purpose. An incorrect VLAN setting can cause traffic not to pass. Typically, the settings that you're going to run into are either tagged or untagged. Untagged means pass anything that comes in without a VLAN tag. Tag means, okay, I'm only going to pass traffic that has this particular VLAN tag on it. So troubleshooting at layer 3, the IP layer, this is where tools like ping come into play. Can you reach that device from a system on the same subnet or a network that's routable to that subnet? Can you reach any other devices on that subnet or on the same switch? I mean, sometimes even the switch has its own IP address. Can you ping that? And connect a laptop directly to the device and manually configure the NIC on the same subnet as the device. You can use a small network switch or a crossover cable if you need to. Most devices, like I said, now automatically do crossover for straight through cables. I mean, if that works, if you can get your laptop and the device to connect directly, the issue is likely elsewhere. So you can continue following that path through any additional switches, routers, patch bays in the system. Just find out where the issue starts. So some additional tools. Traceroute. Again, this is another layer 3 tool. If your network's a bit more complex, involves multiple subnets, you can traceroute between them and maybe see where that IP traffic stops. I mean, this is common if you've got a larger facility that's got multiple VLANs. You've maybe got a router in there that's routing between those VLANs, so you can see whether or not it's actually passing between them and routing properly. And especially if you're dealing with external networks, if you've got your internet connection, and you want to see, okay, is my internet connection, am I able to get to the place I expect to be able to get to? You do a trace route and see where it stops along the way. Now, I mean, it can be a little bit misleading because for external connections, sometimes that traffic gets, it shouldn't be, but sometimes that traffic gets stopped for management purposes. There may be a firewall that says, hey, I don't allow ICMP, which is, what ping and, an internet control protocol, and that's what ping and traceroute are based on. So it may say, nope. But anyway, it's another tool you can use to try to troubleshoot some of these things. I mentioned earlier Wireshark. This will let you troubleshoot layer 2 and above. You can look and see if there's any detectable traffic on the line at all. Now, again, this one you have to kind of be careful because your laptop is inherently going to be spitting out some traffic on its own. So you may have to filter your laptop's own IP address in Wireshark to really not get flooded with all of that extraneous data that your laptop is generating. I mean, Windows can be notoriously chatty. Is there anything being directed at the piece of equipment in question at all, or is there any response from it? You might need to set a switch port to monitor mode to pass all of the traffic rather than just broadcast or multicast traffic destined for the machine running Wireshark. And that's where that little small little managed switch that I talked about earlier can come in handy. So for troubleshooting VLANs, you can try to set it to the same VLAN, see if you're able to attach that way. You can also set it port to monitor mode and use it as kind of a tap on an Ethernet line between devices. So outside internet connectivity issues, first place you want to check is the modem and or the router. Are there any normal, look for normal light indications. Is there anything that doesn't look normal? I mean, typically you'll have a light there that shows whether it's linked for upstream, linked for downstream, and whether or not there's any network traffic on either the external side or the internal network. You can connect the system directly to the router. And if that fails, connect the system directly to the modem itself. Sometimes they're one device, but a lot of times they're also split. You've got the modem or whatever device your ISP gives you to hand off your connectivity, and then you may have a separate router as well. Check with the ISP, see if they're having any issues after you've done all of your own troubleshooting steps and made sure the problem's not inside your plant. And when all else fails, yes, have you tried turning it off and back on again? That's the first question any help desk is going to ask you. Have you tried turning it off and back on again? And the risk is the device may fail in the process or not come back to a functional state. I mean, switches particularly, switches and routers, especially like Cisco or anything with a command line, if that last config was not saved and you reboot, guess what? Those changes are lost, and it may or may not come back up in the state that you expect it to come up in. The other risk is what I like to call power supply roulette. If you unplug it, plug it back in, the power supply may say, especially with switching power supplies, it may say, nope, not coming back. But of course, in that case, it's kind of probably a sign that that device or that power supply was on its way out anyway. And well, at least now you've isolated a problem. We're going to talk now about IT security. The types of security, we've got physical security, facility security, and access controls. If somebody gains physical access to your devices, all bets are off. We want to talk about securing that hardware, including locked racks and enclosures. This is especially true where other people may have access to it, or at least to the space. Electronic security. Look at passwords. You want to set a pretty strong password policy. What I recommend to people is not necessarily the complex letters and numbers and random stuff, but a passphrase more likely that you can easily remember, but would be really difficult to actually brute force. And maybe throw a number or punctuation in there if it makes it even stronger. But yeah, it's a lot easier to remember passphrases that can be really long but memorable than it is some random password. Firewalls, you want to make sure those firewall rules are set up properly and that you can't get in from the outside unless you absolutely need to. And typically what I like to see is a firewall that's fairly well locked down on the outside, that the only inside connectivity comes in over a VPN connection, a virtual private network connection. If they can't see it, they generally can't hack it. Two-factor authentication is another way to secure systems. That means something you know and something that you have. So, for instance, your password and maybe an app on your phone or something that will show you a special key for that particular session. And then, of course, there's the human factor. Humans are the last line of defense when it comes to IT security. And I would venture to say the vast majority of hacks and ransomware and all of this stuff aren't necessarily because someone, quote unquote, hacked your system. It's more like somebody clicked on something that they shouldn't have. Hopefully you've got other things in place to help mitigate some of that and control the damage, offline, offsite backups that you've checked and made sure are regularly updated, appropriate security software on your systems, all of that fun stuff. Staff training is probably the biggest thing against social engineering, making sure that they know what to look for in these emails, making sure that nobody is able to, that they know what, these various social engineering attacks you get phishing emails, you may get voicemails or vishing, you may get SMS messages or text messages, smishing. So yeah, have them know the potential attacks. So with outside connectivity, it's difficult to create island networks anymore, and outside connectivity is almost becoming a necessity for whether it be for vendor support or whether it be for your own access to get in and manage things remotely. But the internet is not a friendly place. There are bots that are constantly scanning for things out there on the network. Your firewall is your first line of defense. If it can't be seen, like I said, it's less likely to be hacked. There's a website called shodan.io. And if you search that for a particular manufacturer, there's a shocking number of codecs and transmitters out there and other devices, other broadcast infrastructure on the public internet. I still can't believe it. It's just amazing, the number of people who just plug something into the internet with no protection whatsoever. Worse yet are the ones that still have default passwords and are set up that way. So again, not hacks per se. It's more, again, the human factor of not setting it up properly. So some best practices: keep your systems up to date, run proper antivirus software, use fault-tolerant hardware. You want offline and offsite backups. One thing to look at are the PCI standards, payment card industry standards, or sometimes PCI DSS, PCI data security standards. Very stringent. And if you deal with cardholder data at all, something that your facility may have to deal with or probably should be dealing with. Security through obscurity is almost as bad as no security at all. So just because, oh, I've got this random port that something is on, nobody uses that port. I've got that port poked through to my device, from the firewall. Sorry, it will be found at some point. Dual homed systems, I don't generally recommend that. It's got to be done with caution. It used to be pretty common practice, but these days, the risk is if somebody gets into one of those networks on that system, then they can get into both of them. And now you've got two networks that have been compromised. Better approach is to actually use routing between different networks. And appropriate access control lists and other restrictions at the router and the switch level. Use the two-factor authentication for all of your sites and logins that you use externally, things like Google or any other number of sites that offer two-factor authentication. It's something you know and something you have, as I mentioned. Strong passwords and passphrases, and VPN for remote access to your facilities. And once again, port forwarding, do it with extreme caution. It's security through obscurity, and it's just a matter of time if somebody will find it. Consider establishing site-to-site VPNs instead. I mean, it's not as difficult as some people make it out to be. In fact, some devices, really, it's just a few clicks and you can set up a VPN on these routers. But one of the biggest risks to your infrastructure, emails, phone calls, voicemail, instant messages, and SMS. I mean, even the best security can be defeated by a well-meaning user. I'll give you a prime example. I had a message come in that said COVID policy update. Well, guess what? It was actually a test, and a bunch of people fell for it. So it can. Some of these can be pretty convincing. So you want to make sure that your users are aware of what to look for. Training. There's a site called KnowBefore that actually does exactly that. They will help with that training process. So some of the exploits that we see would be ransomware, viruses and malware, and remote access tools or keyloggers. Along with unpatched systems and OSs, you've got people out there who say, oh, I'm running XP, it's just fine, it's not on the internet. Well, all it takes is one person to plug a USB drive into there, and if something's compromised, virtualization is kind of a nice tool. You'll hear a lot about cloud, but cloud doesn't necessarily have to be, cloud usually is associated with virtualization, but doesn't have to be, an external public internet type stuff. It can be on-premise as well. So it can be used to replace hardware servers. It allows you a sandbox to test ideas and systems. There are actually pieces of software you can get where you can do this virtualization on your own laptop or on your own desktop machine. So you can set up multiple OSs to run right alongside of your existing desktop OS install. And it's a great place to test these concepts. So that really is about it for me. I think we've got a minute or two. Questions?
Yeah, you have a question there in the chat room. Somebody was talking about UDP.
Yep. Sam says, one subject I have trouble with at times is troubleshooting UDP dropped packets, causing crappy audio between codecs, especially on wireless networks between locations. Yes, and that is a big point. You want to generally, in that type of case, where wireless can be subject to taking some hits. So generally what you want to do is, if you're using codecs, maybe you need to increase your buffer time a little bit. Maybe you need to implement redundant streams where if packets are dropped on one of those streams, it may still be, you may still be able to recover those packets on the other stream. You may need to change the type of error correction that you're using. I mean, UDP is kind of interesting, or, because of it, just unlike TCP, UDP just throws it out there and hopes for the best. So on a local area network, that's usually not a problem. But when you're talking about the public internet, wide area networks, yeah, you can and will get packet loss, and you usually account for that with additional buffering, error correction, or redundant streams. So, anybody else?
I had one question here for myself, and that is about self-advertising. So many of the devices now that you buy from different vendors will actually plug and play and announce themselves on the network. Is there anything that you need to watch out for along that realm?
So as long as they stay within your local area network, preferably on their own dedicated network, you're probably okay. But if they start trying to reach out to the public internet, that's where you start wanting to get a little bit concerned. And that's where things like access control lists and rules in your firewall can really come into play, and making sure that that stuff is as locked down as possible. Or, I mean, in some cases, you actually can turn off. I mean, the advertising functions are useful for discovery between devices. In fact, that's how a lot of these systems work. They basically just, advertise themselves with multicast, and that's and that's how they find each other. But yeah, it's definitely something to be conscious of.
Well, Shane, we appreciate you being with us today, and that was some really good information that you shared with us. And I'm sure if anybody has any questions, you'd be happy for them to email you if you give maybe some contact information. And
absolutely, it's stoven@sbe.org.
oh, that's pretty simple. Pretty simple. We want to remind everybody that oh, I'm on the wrong slide here. Let me go through the slides here. The that our program today will actually be available on YouTube later today. There we are. Here we go. So you can go to ABA Engineering Academy on YouTube, and we have all the ones that we've done in the past are archived on that site, and so you're welcome to go and take a look at those. Our next meeting is actually coming up on June 15th. We'll have our old friend Jeff Weldon talking again about grounding, which we're coming into storm season and summertime. Joining Jeff will actually be a senior technician with the Southern Company, which is the parent company of Alabama and Georgia and Florida Power Company. And he's going to talk about, along with Jeff, about proper grounding and how they do the grounding for their grids and stuff that way. So make sure you join us on June 15th. And that will be at 10 o'clock at the same time. Final reminder about our newsletters that we have out. We have a basic radio and television newsletter that comes out on Monday mornings. If you're not getting that, drop me an email and we'll be glad to add you to that list. And then our new Pro Audio Review newsletter that we just started about 3 weeks ago, and it is just really catching on. There's a lot of people that we found out are involved in that. And Shane, you'll be interested in this. There's a lot of the people that we talk with that's in the industry that are using Dante for their, especially for live sound. So you just run a Cat5 up to the stage, and you can, I think Dante says they'll have like 512 audio channels bidirectionally uncompressed, which is, that's a lot of data on one particular Cat6. And then John Cooper, who's the front of house mixer for Bruce Springsteen. The reason I brought the thing up about the dual engines, that's what they use. Their console has an engine, and that particular console manufacturer doesn't have a way to do it, but through some creative thinking and design, they added a second engine so that they're in the middle of a show and their engine fails, it will just automatically switch over and use that one as all. So thank you again, Shane, for being with us, and John, for you being with us. I think John's going to head out to do some inspections later today, but we'll be back with you again on June 15th, and we thank everybody for watching today. So long, everybody.